In this ANSYS tutorial video, we will be looking at Lab 2 question number 1. Before we get started, we first have to determine which units we're going to use throughout this question. Looking at the units they give us, our best option is to use the SI column of the table of consistent units. Doing so, we are going to convert all of these units here into pascals and meters respectively. So this is where I did that right here. Next, we can move on to defining our element type, material properties, and real constraints. So we know that our element type in this question is going to be a solid, and since they give us a thickness, we're going to specify that as a plane with thickness under the element type tab. Our material properties given are elastic modulus and Poisson's ratio, so we're going to have to enter those in too. And we need to specify the thickness that they gave us. So under real constraints, we're going to enter in the thickness. When creating this model, a couple things stand out to me. One being that it's symmetrical about this axis right here as well as this axis right here. And to simplify the model as best we can simply model one of these little quarters here, and that will have the same effect as modeling the whole thing. The only difference being it'll take up less time to compute the solution. So doing that, the shape that we're going to have is going to look something like this right here, with a pressure load being applied right here, and two symmetry constraints on these lines. To model this odd shape, first we're going to create a nice square with the dimensions, and then we're going to create a circle over top of this rectangle. Then taking the two, we're going to subtract them, which will give us our final shape. For meshing, question B asks us to specify the size as being 0.015 meters. So that's what we're going to input the first time we go through this question. In terms of constraints, we know that this is symmetrical along this axis and this axis right here. So we need to specify that in ANSYS. So to do that, we're going to select on symmetry body constraints and specify that these two lines are symmetrical. Next, for loads, we are simply going to apply a pressure load to this line right here, and it's going to be evaluated at 1,000 pascals. So we can move on to actually creating our model now. So we're going to open up ANSYS, and our first step was to define all the element properties. So to do that, we're going to open up the preprocessor tab, element types, add, edit, delete, add. This time we're creating a solid model type, and make sure we select the 8 node 183 right here. Click OK. And this should now appear. And to specify that this solid model has a thickness to it, we're going to go under options right here, and we're under K3 we're going to select on plane with thickness right here. Going to click OK, and then we're going to close this down. Next, to define the material properties, we're going to open the material properties tab, material models, structural, linear, elastic, isotropic, and we're just going to enter in our elastic modulus and Poisson's ratio, like so. Okay, we can close that down. And for our real constraints, we have to specify the thickness of this plate. So we're going to go under real constraints right here, add, edit, delete, add, and type 1 should be highlighted. We're going to click OK. And now it asks us to enter in our thickness. So we're going to enter in 0.005 meters as our thickness. Click OK. And we can close that down. Now we can move on to actually creating our model. So to create the model, we're going to open up the modeling tab here, create, and originally we specified we would make the square first. So we are going to go under areas, rectangle, by two corners. And here it asks us to input a starting coordinate, our width, and our height. So looking at the diagram, we know we're going to start it off at the point 0, 0, so our origin. Our width is 0.25 meters and our height is 0.25 meters as well. Click OK. And now we have a blue square on our screen. So we can move on to creating the circle here. And to do that, we're going to close down the rectangles tab here and open up the circle tab and click on solid circle. Same thing here, they ask for a starting coordinate and a radius for a circle. We're going to start it off at the origin once again, and the radius is 0.025 meters. Okay, so now we should have this weird looking shape on our screen. Notice how there's a faint white line here showing that the two are laid over top each other and not one area. So that means we have to still subtract the two from each other. To do that, we're going to close down the Create tab here and open up Operate under Modeling. We're going to click on Boolean and subtract areas. And the first thing it prompts you to select is the area you're going to subtract from, which in our case will be the square. We click OK. And next it prompts you to select the area that will be subtracted from the original area. So in this case will be a circle. Click OK. And then now we have that little cutaway piece that is given to us in our example. So we can close down our modeling tab and we can move on to meshing our object, which to do so we would click on the meshing tab, mesh tools, and we're going to set the element attributes to areas. Click set, and we're going to select on our area. OK. And once again, we see all of our material properties, our real constraints, element type are all here. So we can go ahead and click OK. We are then going to select on size controls, areas, and we're going to select on our area. OK. And they ask for our element edge length, which question B asks us to specify 0.015. So we're going to enter that in right here. Okay. And we can go ahead and mesh our object. So click on the mesh button, click on the area, okay. And we should get these white grid lines on our area. Let's go ahead and close that down. Next, we can move on to constraining our object. So we're going to close down the meshing tab here and close down our preprocessor tab and go to our solutions tab, define loads, apply, structural, displacement, and we're going to select symmetry body constraint right here, and we're going to select on lines. So we know that this line right here and this line right here are symmetrical, so ANSYS will know when it's solving the model that this model is basically continued in the other three quadrants, essentially. So make sure you select those two lines, click OK, and these little S's should appear. There are arrows shown, but they're hidden by the area itself. So now we can go ahead and apply the loads. And to do that, we're going to close down the displacement tab, and we're going to open up pressures tab again here under structural. Click on lines, and we're going to select the outer edge here. Click OK. And we are going to give this value of 1,000 pascals as a pressure. Click OK. And now we should see an arrow right here. Notice how this arrow is pointing in the wrong direction. That's because pressure will always push inwards on an object. So to correct that, we will have to first delete this pressure and change the value to negative in order for it to face outwards like it is given to us in the question. To delete it, we are going to close down the Apply tab here and open up Delete, Structural, Pressure, on Lines. And we're just going to select the line out here, click OK. And now the red arrow should disappear. So we are good to specify a new pressure now. To do that, open up the Apply tab, Structural, Pressure, on Lines, and once again we're going to select the outer line, click OK. And since 1,000 push inwards, we're going to change it to -1,000, which will push outwards on the plate, which is what is given to us in our question. Click OK. And now the arrow direction has changed. We can go ahead and close that down and solve our model. I'm going to click on the Solve tab, current LS, OK. Going to click Close, and now our model is fully solved. So we can go ahead and see what the question wants us to extract from this example. And first they ask us to show all the body constraints, which is easy enough. Just click on the Plot Controls tab, Symbols, all BCs, click OK, and it'll show us our pressure line right here, as well as our symmetry constraints here and here. Next, they ask us to graph the von Mises stresses using different mesh sizes. So to do this, all we have to do is just change the mesh size and solve the model again. And to do that, all you have to do is open up the preprocessor tab, go down to meshing, and then mesh tools again. And if you ever want to change the mesh size, let's say you made a mistake, or in this case, you want to keep changing it to see if the solution converges or not, you're going to simply click on the clear button here, select on the mesh you want to clear, click OK, and that'll completely clear your mesh. Now to display the area once again, we're going to go to Plot, and we're going to click on Areas, and that'll just display the area so we can see what we're working with. And to change the mesh size down to 0.01 meters, we're going to change our size controls. So click on Set, click on the area again, OK, and here's where you'll change the value, click OK. And then we're going to select on mesh, our area, OK. And now we have a new mesh that's even smaller than the one before it. And everything from here on out is the exact same. So I'll just go through that once with you guys. So we're going to close on preprocessor, define loads, apply structural displacement, symmetry BC on lines. And we're going to have to specify our pressure. And we can go ahead and solve it. So for the 0.005 and 0.003 meter mesh sizes, you're going to just repeat the same process we did with changing the mesh size, and you're going to apply the same body constraints and same pressures as before. All right, next C asks us just to determine the max stresses on our plate. So to do that, we are going to close down the Solutions tab, open up General Postproc, and we are going to go down to Plot Results, Contour Plot, Nodal Solution, and we're going to select on Stresses here, and we're going to scroll down and select on von Mises stresses, click OK. And here we'll get our color contour with our plate. So this bar down here is all the different pressures from low to high. And if we were to zoom in a bit, we'll see that the red area is right here. So this will be our max stress on our plate, which will occur right here, and it'll have a value of 3005 pascals in this example.